Higher chemists, this one is for you. This is one simple thing you can do anytime you're asked about the polarity of a molecule that will make your life so much easier. A lot of the time in the SQA higher chemistry exams, you'll be presented with a molecule and asked about its polarity. Or you could be asked about its solubility, but that is linked to its polarity. But the best thing you can do to help yourself with any of these molecules is to actually label on any dipoles. So to do that, all you need to do is look up the electronegativity values for each of the bonded atoms in your data book. Let's start off with this one. We've got hydrogen, and if you go to page 12 of your data booklet, you'll see hydrogen's electronegativity is 2.2 and chlorine's is 3.2. Because chlorine's electronegativity is higher, that means it's going to end up being partially negative. The more electronegative one becomes negative. So then all we do is actually label those on our wee molecule. Then you should be able to see straight away that this molecule has a permanent dipole. It has two oppositely charged ends, which means it is polar. Then I've basically gone and done it for all of the molecules that I have here. And you'll notice I've not done it on this one. And that's because phosphorus and hydrogen have the exact same electronegativities. So there are no partial charges. So straight away you can say that this one is non-polar because it does not have any permanent dipoles. Now, carbon dioxide is one you need to watch out for because although that looks like it does have a permanent dipole, it actually doesn't because both ends have the same charge. So because it is a linear molecule and both ends have the same charge, it is actually non-polar because it has no permanent dipole. Then by rule of thumb, any angular shaped molecule that has partial charges will be polar. This is because their angular molecular shape results in them all having permanent dipoles. The same goes for trigonopyramidal. If you have a trigonopyramidal molecule that has partial charges, then it will also be polar. And then for tetrahedral, the trick I always tell people is to look at the charges around the outside. If all of these partial charges around the outside are the same, it is non-polar because it has no permanent dipole. If one of the partial charges is different to the others, then it will be polar because it does have a permanent dipole. So don't forget, if you're asked about the polarity of a molecule or its solubility, the first thing you need to do is look up the electronegativities of bonded atoms and label the polarities. And if you want a more full tutorial on this, then you can head to my YouTube channel, go to my higher playlist, and you should be able to find the polar and non-polar molecules tutorial. Bye!